Good day, students. Welcome to another session for Chemistry 0620 IGCSE. Today, I'm just going to revise question 1, which came in May-June 2017, paper 43. This is the extended version of the syllabus called Chemistry 0620. Okay. In a moment, I'll share my screen. This was question 1, which was based on atomic structure. You should be familiar with the use of the periodic table and how we can use it to determine the structure of the atom. So this question was basing on the subatomic particles, which are the protons, the neutrons, and the electrons, and also the concept of isotope. Okay, let's just go through question 1, and let's see how we are going to benefit from the answers which we can get from there. I'll share my screen in a moment. Right, so like I said, this is chemistry, paper 4, theory extended 0620, paper 43. This was the May-June 2017 paper. Okay, let's go straight to question number 1. Which reads 6 different atoms can be represented as follows. So you have those atoms A, D, E, G, J, and L. So we want to look at how we can use the numbers, the mass numbers, and the atomic numbers in order to answer the questions that are following. Okay. All right, so let's look at number 1, okay? Number 1 was saying which of these atoms has 7 protons, okay? Right, we have to analyze what we are given here, okay? So obviously the numbers that are bigger will be the mass numbers, because in a mass number you have the number of protons and you have number of neutrons. So whenever you're given these two numbers, the number which is bigger for our notation here, the number at the top is going to be our mass number. And then the number at the bottom is going to be our atomic number. Okay, so it's saying which atom has exactly 7 protons. Okay, so proton number is always equal to atomic number. Okay, so we analyze, we have 1 here, we have 2, we have 6, we have 6 here, and we have 7. So that one which will have atomic number is going to have 7 protons. Okay, so we are going to say J is going to be our answer here. Atom J is one which is going to have exactly 7 protons. So our answer here is going to be J. Okay, all right, and then has exactly 6 neutrons. Okay, remember, students, when we want to find the number of neutrons, you take the mass number minus the atomic number. That's how you get the number of neutrons. Always subtract the mass number minus the atomic number. Okay, so if you do your subtraction, 3 minus 1, you're going to get 2. 3 minus 2, you're going to get 1. 12 minus 6, you're going to get 6. Okay, so it appears our answer here is going to be E. Okay, right, but you can check if you want. 13 minus 6 is going to be 7. 14 minus 7, you're going to get 7. And 19 minus 9, you're going to get 10. So has exactly 6 neutrons, our answer is going to be E. Okay, right, so if we move on to the next question here, which is actually saying has more protons than neutrons. Okay, so I have to analyze how many protons I have throughout, and then when I subtract and I look at how many neutrons I have. Okay, for instance, if you look at A, 3 minus 1, you're going to get 2. Okay, right, 3 minus 1, you're going to get 2. Right, and you're going to have 2 neutrons. So this one actually has more neutrons than protons. Our question here is has more protons than neutrons. Okay, so more protons than neutrons. Okay, if you say 3 minus 2, all right, you're going to have 1 neutron. Okay, but in D you have 2 protons. So D is satisfying what we are being asked here. Okay, 3 minus 2 is 1 neutron, but we have 2 protons. So our answer for this one is going to be letter D. Okay, our answer for this one is going to be D. I hope you are following how I have concluded that my answer is actually D. Okay, right. So we move on to the next one. Okay, let's move on to the next section and see what they are asking us here. has electronic structure 2,5. When we're talking of electronic structure, we are looking at electronic configuration, how the electrons are arranged in the atomic shells, okay? So we need to go through from A to L and analyze which one is going to have electronic configuration 2,5 or electronic structure 2,5. Remember, for electronic structure, we use the atomic number, okay? Electronic configuration for this one is going to be 1. For this one is going to be 2. And for that one is going to be 2, 4. This one also 2, 4. But this one is going to be 2 and 5. Remembering that when we are doing electronic configuration, the first shell is always going to have 2, and then the subsequent cells can occupy 8, 18 in that way. So for this one, which is saying has electronic structure 2, 5, okay? Electronic structure 2, 5, we are going to have our answer as J. Okay, so our answer here is going to be J. Okay, right. Is an atom of an element in group 7 of the periodic table. Okay, is an atom of an element group 7. All right. Group number is always affected by the valence number of electrons in the valence shell. Okay, so you have to do the electronic configuration of all the elements. If you do electronic configuration of all the elements, you are going to find out that if you do electronic configuration of L, okay, if you do electronic configuration of L, you are going to find out that you have 9 electrons here. So the first shell is going to have 2, and then you're going to have 7. Okay, so L, okay, is going to give you electronic configuration L. So if they say has electronic configuration 2, 5 is going to be L. Why? Because L is atomic number 9, and because it's atomic number 9, it's going to be in group 7. Okay, and then they say is a noble gas. Okay, noble gas refers to an atom whose outermost shell is full. Okay, if you look at A, the outermost shell is not full at all. Okay, we only have 1 electron. Let's look at D. That's the atomic number. So the electronic configuration is going to be 2. Okay, and that's the only shell that we have. Remember, the first shell is filled by 2 electrons. So it means D is going to be a noble gas. Why? The electronic configuration for D, remember, is only going to be 2. And because it's going to be 2, it means for our D, this one is going to be our it's going to be our noble gas. Remember, if you have your periodic table, and this paper will be having a periodic table, actually element D is an isotope of helium because it has 2 electrons in the valence shell, and helium is a noble gas because its outermost shell is full of electrons. Okay, right. Let's move on to the next one. All right, let's move on to the next one and look at what was the question here. Right, we want to define the term isotope. Okay, what is an isotope? Before we answer this question, we can also analyze what's happening up here. Isotopes, right? Basically, isotopes must have the same proton number, the same atomic number. Okay, so before we answer question, which is going to ask us to define the term isotope, if we look at these 2 elements here, okay, if you look at these 2 elements here, E and G, okay, there is something similar about them. Okay, the proton number is the same. Okay, meaning to say they are going to be isotopes. They are going to have the same proton number, the same atomic number, but different mass numbers. So in essence, E and G will have similar properties because the electronic configuration is going to be the same. If you do the electronic configuration of E and G, you are going to write 2 and 4, okay, for both, because they have 6 electrons. If you do the electronic configuration, you are going to have 2 and 4 there because of the fact that they are going to have the same electronic configuration. Okay, all right, fair and fine. Let's just look at the definition now for isotope. Okay, I'm going to write down the standard definition for isotope, so that we'll be in a position to remember it if we are asked. Okay, what is meant by the term isotope? Okay, I'll write down the definition for you so that you have a standard definition for isotope. Okay, right. So suppose we are saying, what is an isotope? Okay, what do we mean by an isotope? All right, isotope, you could write your answer as isotopes. These, okay, can say these are atoms of the same element with the same proton number, but this one is very important, but different number of neutrons, but different number of neutrons. Okay, if you want to say, you can also say but different mass numbers. So this idea of the fact that they are atoms of the same element, the examiner wants to say that, okay, they should have the same proton number, but what is different about them is the fact that they have different mass numbers, or they have different number of neutrons. Okay, right. So this is the definition that you are supposed to have: isotopes, atoms of the same element, same proton number, but different number of neutrons. Okay, all right. So if you go back to what we were discussing at the top there, okay, you actually find out that if you look at these atoms, okay, and then a person were to ask you from this list, pick, okay, atoms which are isotopes of each other, like I indicated previously. Okay, if you look at E and G, which was the next question, if you look at E and G, you're going to find out that for these two, E and G, okay, you're going to find out that they are actually the same. Why? You look at that one, 6, and that one, 6. Our definition was saying atoms with the same proton number, but different mass numbers. Different mass numbers. The numbers which are at the bottom, they are the atomic numbers, and they are different. And if you also check, the other question was, why do they have similar chemical properties? Okay, if you're going to look at why do isotopes have similar chemical properties, we could answer this question as follows. Okay, we could say, just extend this a bit. Okay, right? We can say this is because isotopes have the same number of electrons which are arranged in the same way. Okay, right. So you could also say this is because isotopes have the same electronic configuration. Okay, but the examiner here wants you to focus on electrons, because if you look at your protons, your neutrons, and your electrons are found in atomic shells, and electrons are the ones that are involved in chemical reactions. So chemistry mostly is about electrons. We are moving electrons. Either we are transferring electrons completely, and then we have ionic bonding, or we are sharing electrons, and then we have what we call covalent bonding, or we have delocalized electrons, and then we are talking of metallic bonding. So chemistry, in most cases, we'll be talking about electrons. So isotopes could be different in terms of their masses, but in terms of chemical reactions, they are the same, because they have the same number of electrons, and they'll be found in the same group of the periodic table, and they will have the same electronic configuration. This was our revision session for for today. Again, if you want this video and you find this video useful, just subscribe, okay, like it, share it, and discuss it with your friends in your discussion groups, okay. And remember, if you subscribe it, it will enable us to actually be in a position, we have the motivation to produce more videos of this nature. Bye bye for now, students. I will see you in my next session. Thank you. Bye.